The nice thing about this is it's a pre-made unit, and it looks to be a really good value for the price. It's still in the box. I haven't even unpacked it yet, and it's already much smaller than this. And this thing is very heavy. It's based on lead acid car batteries. The interesting thing is this actually has a larger battery in terms of capacity than this. Right on top we've got our user guide. Look at that later, maybe. We've got a couple of cords here. Looks like we've got a wall charger. 12-volt accessory plug. Like to use solar panels, you can add one to do that as well. I'm going to go ahead and hook up one of my solar panels to it as part of this review to see how that works. In here, it looks like everything is pre-assembled, nothing else in the box. And it looks like we're pretty well ready to go. And man, I'll tell you what, this is nice as far as the size goes. I wouldn't take it backpacking, but I'll tell you what, you could carry this a long ways without getting tired. Where this thing, you're going to get tired pretty darn quick. Basic controls, looks like we've got 3 AC outlets here. So these 2 are your inputs. You got 2 styles. We got the barrel input, so we can plug in our wall charger into that, or the cigarette lighter plug. Looks like for the PV, for the solar panels, they've got another style. That's the, oh, I can't think of the name for it, but that's a pretty common connector. And then the rest of these, looks like we've got USB outputs, 12-volt DC outputs with another auxiliary plug. Turn them on and off with the push button. Looks like our battery is about half charged. Generally with lithium ions, or really any kind of battery, it's good to give it a good full charge before you really start using it. So I'm going to go ahead and get it plugged in before we put any loads on it. But it looks like pretty darn easy to turn the different modes off and on. I did read that this one you need to hold for 2 seconds, which could be a nice feature if you don't want to accidentally turn that one on and off. And this is a pure sine wave inverter, which is also an upgrade from this guy. We did a modified sine wave. Modified sine wave is good for a lot of things, but some things are a little sensitive to it. And if you're running anything that you were worried about the sensitivity of the sine wave, a pure sine wave is a better way to go. The problem is they generally cost more money. So I'm not sure what the master power button does. If you can turn... Okay, so if I turn on a bunch of things with this, maybe that will... Yeah, it's like a master switch to turn everything off conveniently. Okay, that's about all there is to it. It's pretty no frills. This is not weatherproof, so you do need to be mindful of that. And that's common. I think most of them are that way. And that's a side effect from having the ventilation on them. I tried to make this one completely weatherproof. When I use this and it's not raining out, I open the lid to give it some ventilation. But realistically, if it is raining out and I have to close the lid, I do have to take that into consideration that this is not breathing properly and I can't load it as much as I would be otherwise. If you only wanted to use this as a portable power source and weren't worried about charging it via solar, you don't need to buy anything extra. That's ready to go. So that's plugged in. There's a green light on this that tells you it has power, and then we go to the DC input here, and as soon as I plugged it in, the battery lights up and it's indicating that it's charging. So we'll go ahead and let that charge for a little bit like that, and I'm going to also go ahead and get my one of my solar panels set up with one of these other inputs right here, and we can see how it charges that way as well. Now when you're picking out a solar panel, if you're going to hook one up to it, there's a couple things you want to check for. You can accept up to 200 watts of solar input, and that it also specifies that the open voltage must be between 18 and 30 volts. So on the back of your panel, you'll want to check, and this is a 100-watt panel, so we're within the 200 easily. We can actually use 2 of these if you want to. Open circuit voltage right here, sometimes labeled as VOC, usually it's written out, open circuit voltage, is 22.5 volts. So that's between our 18 and 30, so we're good. If we wanted to use 2 panels, we can, but because the 22 volt open circuit voltage, we have to put them in parallel. Parallel means that we are going to double the current, not the voltage. In parallel, you wire your positives together and your negatives together, and then run them to your input. Series would double your voltage, but not your current. If we were to wire these in the series with this unit, that would bring us up to 44 actually 45 volts of input, which is above our 30. So we can't do that, but we can put them in parallel. And if you were to run them in the parallel, you can use these MC4 connectors to do that. I've talked about these in my other solar generator build video, the expansion video. So these right here will set it up for parallel, because you would run both your pluses from both panels to this, and then this would go to your input for your power supply unit. And then you do the same thing with your two negatives. Your two negatives go into here, and then this runs to the negative on your power supply unit.
Yeah, I've got 200 watt panels hooked up to it currently. So we've got them wired into the PV in, and the unit is currently charging. Looks like it's at 3 out of 5 bars at the moment.
While I'm letting that charge, I kind of wanted to show the difference. So this is the one that we made homemade with components, and as you can see, the battery that's in this is about the same size as that entire unit. So if that truly does have as much capacity as this one, or even more, if the specs hold out to be true, that's incredible. Now, that's not to say you can't build your own using lithium-ion batteries, and I had a lot of people asking me how to do that. And when I built this, it was a couple years ago. Well, more than that, it's a few years ago now. Most of your solar inverters and chargers at that point in time didn't say they were rated for lithium-ion. They were mostly designed for lead-acid. So we stuck with the lead-acid gel cells for that reason. Lithium-ion technology's come along a little bit since then, and I think there's probably some more inverters on the market that would support that. However, at the same time, there's a lot more of those available than there used to be as well. And for the price, you can get some pretty good options without having to go to the trouble of building your own. That's not to say you shouldn't build your own if you're looking for a project and you like to customize and kind of build things and tailor them exactly how you want them. You can still do that, and building it may be the way to go for you. And it can be fun. You can learn a lot in the process, and there may be still some advantages where if any one of these components fails, you can replace just that component, where with these, you have to replace the entire unit. And that includes the battery. These do not have customer serviceable batteries in them. So when the battery finally wears out, this unit is basically intended to be replaced as a whole. Okay, I've got this charged now. It shows full charge. And if I turn on the DC output and put a multimeter on there, it is reading at 13.28. It does have a timeout. Like you see, the voltage is not showing anymore because it detected that there was no draw. You can turn it back on, it comes back on. I believe the manual said that it will shut off after 30 seconds if it does not see a load. I'm going to go ahead and use the a kilowatt in conjunction with the AC output, just so we can kind of get a feel for how much power we've used. One thing I also noticed is that I've got the DC output, which is currently off, plugged into a multimeter. When we turn that on, we can see 13.28 volts, which I'm assuming is probably wired directly into the battery. And we can also turn on the USB outputs and the AC inverter. What I find interesting, though, I've noticed, is that if you try to plug the charger in, and this appears to be the case with either the solar charger or the wall charger, when you plug this in, it shuts down the DC output. It does leave the AC inverter on and the USB outputs. They remain on, but you even notice the light here for the DC output went off, and we're not getting any battery voltage on the DC outputs anymore, and you cannot turn it back on. So it seems to intentionally turn off this output for as long as the charger's plugged in. I'm assuming this may mean that there's not a regulator on this, and it's probably direct wired into the battery when it's enabled, and it could be that the charger voltage is higher than they felt they wanted to put on these outputs, which could be smart. Some devices, if you exceed the output voltage, usually automotive stuff's good up to about 14, 15 volts, no problem. You start getting into higher than 15 volts and you can start damaging stuff. So it could be that this internal voltage for these batteries do go above that. Okay, the first thing I want to do to test this is I'm going to go ahead and try, I need to do a little angle grinding on this pond deck that I built, or a deck I built out by my pond. And we don't have electric all the way out here, so I've been using a portable diesel generator set because I had a lot of welding to do on this project. However, I've got just a little touch-up work to do. I'm building an umbrella bracket. So I got a little bit of grinding, and I'm going to try to weld in some gussets made out of some U-joints. And for that, I think, because it's a small task, I'm going to try using the solar generator. Now, I think it'll probably work for the grinder. The grinder is a Milwaukee 4.5-inch grinder. It's rated at, according to the label, 8.5 amps, which puts it right around the wattage that this thing is rated for. So I don't think we'll have a problem with this. I'm also going to take a chance and try doing the welding with a small 120 volt MIG. Well, I'm sorry, not even a MIG. It's a flux core 120 volt welder. And they call it a flux core 80, but it's actually 65 and 70 amp depending on the setting that you choose. I'm going to start it on the low setting and see if it'll work with that, and then try it on the high setting. Now that may not work. That's pushing the wattage that this guy's rated for. But I need to do the project anyway, so I thought let's give it a try. So let's go ahead and start with the grinding. Okay, so that worked, but the grinding's done. Let's see if we can run the welder. Welder powered on okay, but there's not much load until you actually start welding. The true test will be when I first start striking arc. We'll see what happens. No go for the welder. It faults out. It's faulted out both times that I tried. I can't say that I'm surprised. This welder is asking too much for what this is rated for. And to be fair, that's not a fault against this thing. None of the other inverters that I've tried so far have been able to weld with either. So I'm going to go ahead and use the diesel generator set to finish my welding. But I do need to do some painting later with I have an airless sprayer that I use, and I'll probably go back to trying to use this for the painter, and I expect it will work for that. Here's the welded in piece with the gussets that I added. Just used a couple of old U-joints trying to do something a little different. I'm not sure if I like it or not, but they're in there now, so I'm probably going to leave them for a little bit at least.
got a small pond over here that has a fountain that he uses for aerating, and it's running on a submersible half horsepower pump. And we were curious to see how that would work on this, if we could run it with the power station. I'm going to switch this back to wattage. We're going to go ahead and unplug the fountain. This would be a good test to see if this would work for somebody that did not have AC and wanted to be able to run a fountain occasionally on their pond for aeration. Probably wouldn't be able to run it all the time, but they could charge this up and then potentially run it for several hours at a time. So we're going to go ahead, we have it already set up with the output turned on. We're going to plug it in. The fountain immediately came up. Looks the same as it did when it was plugged in. And we are pulling 426 watts. Now I missed the startup surge, so let's do that again. See what kind of surge it has. Actually does not appear to have a very big surge, surprisingly. So that motor starts up without a lot of peak current. Either that or it's getting missed by this meter. But either way, the unit ran it, no problem. Seems to have no problem at all running a half-horse water fountain. So that's a success. And we came over here in the silver cart, which I'll be doing another video on that as well to finish up that series. But that has been working very well, and I use it quite a bit, and I never have to plug it in anymore, so it's pretty handy. I've got some grass seeded up there, and it's been dry, so I'm going to see if I can run a pump with this to water some of the seed that I have grassed and strawed on the hillside up here. And so we're going to see if this will run the little submersible utility pump. It's 110 volt. So I just have it dropped into a bucket. I got some holes in the bottom of the bucket so that it will take water in. The idea of the bucket is to just try to keep some of the sediment out of the pump. We're going to go ahead and plug that into this guy, and this is still reading full. When I turn on the DC output, it's showing the battery at 13.28. If I turn on the inverter and then plug our pump in, we'll see if it stays running. So far it has, and there we're getting some water. The voltage is still staying at 109. And it looks like if I switch to wattage, the pump is pulling about 230 watts. This is just a little quarter horsepower pump. It's showing 220, 224, and then if we open it up, Actually, wattage is staying pretty similar no matter what we do. Okay, we are at 0.80 kilowatt hours. That's been running now for a little over 3.5 hours, 3 hours 38 minutes. And we still show 1 bar on the battery meter. And the DC output is 13.27 volts. So what a kilowatt hour is the way that math works. If you used 1,000 watts continuously for 1 hour, that would be a kilowatt hours. 1,000 watts is a kilowatt. So we are currently using 223 watts. It's fluctuating a little bit, about 220 watts. And like I said, it's been running for 3 hours 40 minutes. So the same math works out to, that comes up to 0.81 kilowatt hours. That's pretty good. We're approaching a full kilowatt hour out of this guy. And that's more than I was expecting. I didn't expect to be able to run it for a full hour at 1,000 watts, which would be about the same amount of power usage. As you go higher in wattage, though, it will generate more heat, so you'll probably get more efficiency out of it at lower loads. Like this 200 watts, though, seems to be doing really well. The fan only kicks on every once in a great while, so it seems to be staying cool pretty well passively. I'm pretty impressed. Pretty happy with this thing.